morning? Thank you. That was very gracious. For giving him a pen.
Oh.
Yes.
He's been up since 5 a.m.
Yeah, I agree. That was very kind of you. Solve, simplify, factor. Solve, simplify, and factor. Okay, so when I say the word solve, and thinking from a mathematical perspective, what comes to mind about solving? Solve. What has to happen?
Finish the problem.
Okay, so finish the problem. What does that look like, finishing the problem? Okay, finish the problem, and then I heard x equals or y equals. X equals something, y equals something. Okay? When we are trying to solve for x, what's the rule when we're solving for x? What do we have to do? Get it by itself. Okay, that's called isolating the variable. So we are going to isolate the variable. What math symbol is always, always, always present when we're solving? Equal to. Okay, and I'm going to expand that a little bit, because could we have greater than or equal to, and greater than or equal to? Could we have those also? Okay, good. But equal to is really the thing that we think most about when we are solving. Okay, so we are finishing the problem. We are isolating the variable. We have x equals some number. Okay? That's what we're doing when we are solving. We are trying to find a value for the unknown variable. And the directions will say solve. That's what the directions will say. They'll say solve. Okay? Now, simplify. Simplify is what we did last week. All of last week we were simplifying. Okay? So what does that look like? What did we do last week? Good. Combined like terms. Okay? What else did we do last week? What rules did we have to follow? X squared times x to the third equals x to the fifth. Okay, are those our exponent rules? Okay, so we talked about exponent rules last week. Okay, what other properties did we have to do? Did we FOIL? Distribute? Okay, when I'm simplifying, what does my answer look like when I'm simplifying? Okay, a smaller number. Do I have variables in that too? Yeah, so and my answer may be something like x squared minus 2x. Okay? There is never an equal sign. When we are simplifying, there's never an equal sign. We are putting everything together. Okay? We're combining everything. Okay. So, kind of our key word here is combine. Oops, that's not spelled right. How about combine? That's kind of our key word. That's what we did last week. We added what could be added. We simplified exponents. We divided when we could. All of those things. This week, what we're going to do is we are going to factor. That's our focus this week, is factoring. Factoring. Okay? When we factor, we are breaking expressions apart. Okay? We are looking for things like the greatest common factor. Okay? We're asking questions like, what is common? What is common? Okay? So our key word with factoring is break down. Okay? That's what we're doing with factoring. We're breaking down. Now, my beginning, when I'm factoring, the beginning of my factoring problem looks like the end of my simplifying problem. Okay? We are working backwards. When I am factoring, we are working backwards. We are starting with what we think as the answer, and we are breaking it down to the original problem. That's what we're doing when we're factoring. We're trying to go back to what we started with when we were simplifying. We're working backwards. Now, what happens is once we get to factoring is students don't know where to stop. Students don't know where to stop. Okay? And that's the difference with the factoring. Okay? Is they think that they've gone back to the beginning. So they've got kind of two binomials and they think, oh, I'm supposed to multiply that together. I'm not supposed to leave it like that. So that's the difference between simplifying and factoring is where do you stop? And that's what we're going to focus on this week. We're going to focus a lot on factoring. So here we go. Let's get started. Now, when we factor, the very, very first question we ask ourselves when we are factoring, is there something common? Is there something common to all terms? Is there something common to all terms?
3x squared.
Okay? Yes, 3x squared. In this particular one, it is 3x squared. But that's what you're asking yourself. Is there something common to all terms? And if something is common to all terms, that's called the greatest common factor. And it doesn't matter what you're factoring. Always ask yourself if I have a greatest common factor that I can factor out. Because when there is a greatest common factor that you can factor out, it does make it easier. It does make it easier when you have to factor later on. So sometimes you may factor using the greatest common factor, and then you may factor using grouping or another technique that we're going to talk about. Okay? So the first thing that we're going to do is we're going to look at our numbers. I have 3, I have 15, and I have negative 21. So I am going to ask myself, is there a number that is common that can be factored out of 3, 15, and negative 21? What can be factored out of all of those? 3. Okay, so I am going to factor out a 3. Okay? Now, the next thing I'm going to ask myself, what can I factor out here between x to the 4th, x to the 3rd, and x squared? What you are looking for is your lowest exponent. What is my lowest exponent there? X squared. So x squared is going to be what I factor out of all the variables. Okay? So, first thing I'm going to look at what 3 times what gives me 3? 3 times what gives me 3?
1.
Good. X squared times what gives me x to the 4th? Good. Okay, now we're going to do it again. 3 times what gives me positive 15? Plus 5. Okay? Now I've got x squared times what gives me x to the 3rd? Okay? Now our next one, I've got 3 times what gives me negative 21? Negative 7. Good. Okay, and this one, x squared times what gives me x squared? X squared times what gives me x squared? 1. Okay, a lot of times students will be tempted to say nothing, but what is x squared times nothing? 0. Okay, so don't say nothing. Be careful with that. Okay, so what I have done here is I have factored out 3x squared. And I'm left with x squared plus 5x minus 7. So that is my final answer right there. 3x squared times x squared plus 5x minus 7. Okay? Okay, can we do the next one? Okay, now we're going to ask ourselves 3 different things for this one. First thing is, what is common to 8, negative 2, and negative 12? What's common to all of those? 2. Okay, so that's what I'm going to ask myself first. The next thing I'm going to ask myself, what's common to x to the 3rd, x to the 4th, and x? What is common to all of those? Just x. Okay, so I'm going to factor out an x. Now I have another variable that I have to look at. I have y squared, y, and y squared. What is common to all of those? Okay? So now I'm going to do it the same way. I'm going to look at the 2. So I'm going to ask myself, 2 times what gives me 8? Good. Then I have x times what gives me x to the 3rd? X times what? X squared. Good. X times x squared gives me x to the 3rd. What about y? Y times what gives me y squared? Good. Okay, I'm going to do it again for my next term. 2 times what gives me negative 2? It's not 1. It's negative 1. Don't forget your negatives. Sometimes those negatives can get confusing. Okay, then I have x times what gives me x to the 4th? X to the 3rd. Y times what gives me y? Good. And we're going to just put the times 1 right there for now, because sometimes that helps. Okay, now let's go back to the 2. 2 times what gives me negative 12? Okay. X times what gives me x? And it's times 1. Good. And then y times y gives me y squared. Okay, and then so I have factored out a 2xy, and I'm left with 4x squared times y minus x to the third minus 6y. Okay, so I have factored out a greatest common factor. Now, for these, we're not going to go any further. But as we move on, and we'll see the very last one that we do today, sometimes you factor out a greatest common factor, then you factor something else. Okay? And that's an important thing for us to look at and to make sure that we understand. Okay? Can I go to the next? Yes, sir.
On the second one, do you want us to factor out the negative too? And just make it all positive in there? Make the majority of them positive?
I would not factor out a negative unless the very first term is negative. Okay? It's not wrong to factor out a negative for this. You certainly could. But I typically don't unless the very, very first term is negative. And that's when I factor out a negative. But if you factored out a negative 2, your problem would still be correct. Okay? Okay, can I go to the next screen? Okay, so that was greatest common factor. That was greatest common factor. What we're going to do now is we are going to factor by grouping. Yes?
I have a question on the
Right there?
yeah, so we don't put the negative 2x over the 4 like the first one? Because like the x and the 4, and like that's greater than the x in the third.
But we factored out an x. So we factored out this x right here. Okay? And so we only have x to the third left. So you're talking about this x to the fourth right here? Yes. So x times negative x to the third, that's going to give us x to the fourth. So we have factored out of this term right here, we have factored out a 2xy. So if I were to multiply 2xy times negative x to the third, I would get this term up here. So we are breaking it down. That's why we have smaller exponents. Okay, thank you. Okay. Now we're going to factor by grouping. We're going to factor by grouping. Okay? I would still get into the habit of asking, is there a GCF? The first thing you should look for when you look for factoring is trying to decide if there's something that can be factored out of everything. Okay? Is there a common variable to everything? Is there a number that can be factored out of everything? Okay? When there is, you want to factor that out first. Okay? In this situation right here, there is not. So what I'm going to do here is I am going to look at these first two terms. This is factoring by grouping. So I am looking at these first two terms. What is common to both of those? B squared. B squared is common to both of those. Okay? Then I've got B squared times what gives me AB squared? A. Then I have B squared times what gives me negative 4B squared? Minus 4. Okay? Now I'm going to look at these two terms right here. What comes out of both of those? Okay? 3 times what gives me 3A? 3 times what gives me negative 12? Good. Now, for this to work, A minus 4 and A minus 4 must be exactly the same. If they are not exactly the same, factoring by grouping doesn't work. Your final answer to this problem is this right here. So even though A minus 4 shows up twice, you only write it down once. You only write it down once, even though it shows up twice. Okay? Now, I want to talk a little bit as to why. Let's think about why that A minus 4 only shows up once. So if I were simplifying, if I had B squared plus 3 and A minus 4, and my directions were to simplify, I would have to use the FOIL method to do that. So when I used the FOIL method, the first thing that I would do is I would have b squared times my first and my outer. Okay? And actually, I'm going to write this down just... I'm going to write this down right here. B squared. So I'm going to take b squared and I'm going to multiply by a, and then I'm going to take b squared and I'm going to multiply by negative 4. So I have b squared times a, then I have b squared times negative 4. That's my F and my O. Then I've got to do my 3. My 3 is multiplied times my A, and then my 3 is multiplied times my negative 4. That's my I and my O, my I and my L. Now, we don't ever write this step down. We don't ever write down, but what I am doing when I do F and O, so I am doing B times A minus 4. That's what I'm doing. When I do my first and my outer, I am taking b squared and I am multiplying it times a, and then I am taking b squared and I am multiplying it times negative 4. That's what I'm doing, even though I don't write it down. When I am doing my inner and my last, I am taking 3 and I am multiplying it times a minus 4. That's what I'm doing. I just don't write it down. So we really are working backwards. Okay? That's what we're doing when we're factoring, is we are working backwards. So I start here and I work back to this. It's just that for years, we have not written down this step right here because it's taken care of with the F and the O and the I and the L. Because it's taken care of with that. Okay? That's why we don't ever write it down. But this step occurs every time we do this. We just don't write it down. Okay? So that's where that comes from. And that's why we only write down our A minus 4 once. Okay, can I go to the next screen? Oh, no, we've got another one to do. So I've got x squared minus x plus 5x minus 5. Okay, what comes out of the first two? X. So I have x on the outside, and I'm left with what? X minus 1. What comes out of the next two? And then what am I left with? Okay, so I have x plus 5 times x minus 1. Okay, now what I see sometimes is I see students get to this point right here, the x plus 5 and the x minus 1, and they think, oh, that's not simplified. I need to FOIL that. Okay, and that's true when your directions say simplify. So if your directions say simplify, you're absolutely right. You're supposed to FOIL this. If my directions say factor, then I'm done. X plus 5 times x minus 1 is my answer because my directions say factor. Okay? Now I am going to give you 1 minute to do the next one by yourself. what do we take out of the first two? X. What are we left with? X plus 2. Excellent. Okay, now I want us to look at this right here. Negative 3x minus 6. Negative 3x minus 6. Do you see how I have a negative right here on this third term? That is an indication that you need to take out a negative. Okay? When I've got a negative there, that's when I take a negative out. So I'm going to take a negative 3 out here, and then what am I left with? X plus 2, and that's what we want is x plus 2. If I don't take a negative out here, then I'm not left with positive x plus 2. And I have to have them exactly the same. If I don't have them exactly the same, it doesn't work. So anytime that you've got a third term right here that's negative, then you want to take a negative out of that second set. Okay? Okay. Now, so the very first thing that we do, first thing that we look at when we are doing these is we ask ourselves, is there a GCF? Is there a GCF that I can factor out of everything? The second thing when we are factoring that we ask ourselves is, can I factor this by grouping? Okay, that's the next thing I check. Can I factor this by grouping? The third thing that I'm going to ask myself, is this a special product? Specifically, the special product that I'm talking about is difference of perfect squares. So the first thing we want to do before we talk about the difference of perfect squares is we have to remind ourselves, what is a perfect square? What is a perfect square? So if I've got 1 squared, what does 1 squared equal? 1. What is 2 squared? Good. 3 squared? Good. 4 squared? 5 squared? 6 squared? 36. 7 squared? 49. 8 squared? 64. 9 squared? 10 squared? 11 squared? 121, and 12 squared? 144. Okay, so these are perfect squares. And what that means is, if I take the square root of my perfect square, then I get the number to the left. So what is the square root of 81? 9. What's the square root of 25? 5. Okay? So the numbers on the right that I have circled, those are the perfect squares. Now, x times x is also a perfect square. Okay? So x squared is perfect. The other one that students forget is perfect is x to the 4th. We forget that x to the 4th is also perfect. So look for these when you're asking yourself if something is a perfect square. Okay, can I go off this screen? Okay, here we go. Now, let's talk a little bit about the difference of perfect squares. So a squared minus b squared. For something to be the difference of perfect squares, for something to be the difference of perfect squares, this right here must be a perfect square. Okay, and this must be a perfect square. Okay? They both have to be perfect squares. The other thing that must happen is this must be subtraction. All three of those things must occur. All of that has to be true. The first term has to be a perfect square. The second term has to be a perfect square, and they must be combined by subtraction. Must be. Okay? Now, is x squared perfect? Yes. Is 16 perfect? And are they combined by subtraction? Yes. Okay? So, what I've got is one of my binomials is going to be addition. The other part of my binomial is going to be subtraction. Okay? What is the square root of x squared? X. So I'm going to put an x here, and I'm going to put an x here. Okay? What's the square root of 16? Okay, so I'm going to put a 4 here, and I'm going to put a 4 here. Now, we have to have 1 plus, and we have to have 1 minus. Now, if I were to FOIL x plus 4 times x minus 4, if I were to FOIL that, what would happen to those two middle terms? They would cancel out. Okay? That's why difference of perfect square works. Okay? So my final answer to this is x plus 4 and x minus 4. Now, if you wrote down x minus 4 times x plus 4, is that okay? Yes, as long as one's plus and one's minus, you're in good shape. Okay? Let's do the next one. I still have perfect squares. Okay? 4 is perfect and x squared is perfect. Is 25 perfect? Okay? So, what's the square root of 4? What's the square root of x? Okay, so I'm going to put 2x as my first in both of those. What's the square root of 25? So I'm going to have a 5. One of them's got to be plus, one of them's got to be minus. Okay? Can I go to the next screen? Okay. Now, for this one, what I want you to look at, I've always said, what we've been talking about is there a GCF common to everything? Okay? You always want to ask that question first. Is there a GCF common to everything? Then you're going to ask yourself if it can be factored by grouping. Then you're going to check and see if it's difference of perfect squares. Sometimes you can do multiple types of factoring. So, my first one on the up here. Do I have a perfect, or I do have difference of perfect squares, but I also have a GCF. So I want you to factor out that GCF first. What's my GCF here? 9. 9 can come out of both of these. What's 9? 9 times what? Gives me 9x squared. Okay. Then 9 times what? Gives me negative 36. Okay. Can I factor x squared minus 4? Yes, you have to keep going. Always ask yourself, when you think you're done, ask yourself, can this be factored further? Okay? Can this be factored further? So I've done my GCF, and this can be factored further. Okay? X squared minus 4 is difference of perfect squares. What does x squared minus 4 factor to? X plus 2 and x minus 2. Okay, that is because x squared is perfect and 4 is perfect. That's why I do the plus 2 and the minus 2. Okay, now I'm going to give you 1 minute to do the next one. Okay, factor out a GCF first. Factor out your GCF first. Okay, for this one, we have to factor a GCF out first. What's my GCF? 3. 3 goes into both of those. What else is my GCF? Good, 3y. So I'm factoring out a GCF first. Now, you might have thought that that was all that could be factored out. Okay, so 3 times 16 gives me 48. Y times y squared gives me y to the third. Then 3 times what gives me negative 27? Negative 9. Y times 1 gives me y. A lot of students will stop right there. They're like, I factored out my GCF. I'm done. But am I done? No. What can be factored out? What can happen to 16y squared minus 9? Difference of perfect squares. Okay? So, what is the perfect square of 16y squared? 4y. So I have the perfect square of 16. The square root of 16 is 4. The square root of y squared is y. What's the square root of 9? Okay? One of them has to be plus, one of them has to be minus. Okay? Okay, so again, this is what we focused on today. We focused on finding a GCF. Can a GCF be pulled out of everything? Always ask yourself that, even if you think it's a difference of perfect squares. So the one on the left was a difference of perfect squares, and we could have gotten 3x plus 6 times 3x minus 6. We could have done that. Okay? But it's easier to deal with if we factor out that GCF first. Okay? The second thing you're going to do is ask yourself if you can factor by grouping. Third thing, is this a difference of perfect squares? On Wednesday, we will focus on trinomials. On Wednesday, we will focus on trinomials. Then on Friday, we'll do word problems. Okay? I will see you guys on Wednesday.